Hey guys, hope everybody's weekend was all right. We're getting into our next unit today. This is 4.1. The first thing that we're going to do is scatter plots. I'm going to do this lesson on the student notes instead of the PowerPoint slides printed out. Our last lesson doing this, my video was a little bit shorter. It was only like 15 minutes, so hopefully that'll be a little more concise. So you guys can kind of learn this as quickly as possible and then try it for yourself. Just in case you haven't, go ahead and finish the test from last week for unit 3.3, all of the one variable data stuff. There's no due date on it, but you know, if it takes too much time, I'll just put a 0 in. So do that if you haven't already. You do get 2 attempts on it, and I might do test corrections. I'll probably set it up the same way I did before, but I'll let you guys know when I figure that out and I look at the data from this first test, and we'll see how it goes. Okay, so let's get right into it. We're going over scatter plots. These are just some examples of scatter plots, and the idea behind these are that there are 2 variables. So each of these deals with 2 different variables. So there's one that's going to be, here on the x value, and there's going to be a different one on the y value. And when we go over a few examples of this, you'll see what I mean by 2 different variables that connect in one way. And that's where all of these different data points will come into play. So like, as x increases, y is also increasing. So we're going to go over descriptions, why these look a little bit different, and generally just how to read these and kind of set them up. All right, so in terms of vocabulary, there's 3 things you need to know. Bivariate data is data that involves 2 variables. So basically, a scatter plot. A scatter plot graphs bivariate data as a set of points whose coordinates correspond to the 2 variables. So it's just a way to visualize it, to show it, to represent the data. And then finally, there is an association between the 2 variables. If we see that there is a clear relationship, then we can define that. And the 3 ways that we are going to show that association is a positive, a negative, or no. Now, a positive association is generally when there is a positive slope on that. As the x increases this way, the y is also increasing up this way, causing this linear line right here. It's kind of like an average. It's not exact. It might be a little bit more up, but that's a good kind of just, guesstimate. Same thing here with negative. That's where we're going to kind of start up high, and it's going down low like that. So basically, what this one is saying is, as the y is going down, as we go down on the y, our x is actually increasing. So the value of one variable decreases as the other increases. That's a negative. Think of it like a positive and a negative makes it a negative. Here, a positive and a positive makes a positive, right? Now, sometimes the data is all over the place. Sometimes it's just scattered. You could kind of guess something, but there's not much association here. That's where we say there's no association. It's just completely random. Sometimes you're just looking at 2 2 variables that have just nothing to do with one another. All right. So when the 2 variables in the data set have a strong positive or negative association, you can find a linear model. Think back when we did y equals mx plus b. Think back when we graphed a line on an xy plane. It's the same sort of stuff. We're kind of just going back at that, but with data instead. So basically, when there's a positive or a negative slope that we can generally see, we can create an equation for that. the process of that is called fitting a line to the data or finding a regression line. That basically is the line that I created here and there. So this line is modeled by a linear equation, just like I said. You could also hear me say a function. It's the same thing. The line can be used to make predictions. So, if I know that I start here and I keep going up and up and up, I can predict what's going to happen up here, or I can predict what's going to happen out here. Here, you can't really predict anything because there's no association. All right, to show the first example, we got this guy right here. So this is our scatter plot. It already has given us all the data points and it's given our regression line. So that's right here. So with the exception of some outliers, which is like this guy right here, that's an outlier, there appears to be a linear relationship, meaning there is sort of a pattern we can follow between an animal's body, which is right here, and the brain weight, which is our Y value. So this compares the body weight of an animal to the brain weight of an animal. There is a positive, so basically this line would keep going up, making it positive association, because the trend shows that in general, as the body weight increases, as we continue on this way and the animal gets bigger, the brain of that animal is also getting bigger as well. There's a positive. So as an animal's body weight increases, its brain weight also increases. A regression line is fit to the data. This equation of this line could be used to make predictions about the weight of an animal's brain given its body weight. Ignore this out here. This is for the next page. So basically, we can predict that a 600-pound animal is going to be about, it's going to be somewhere around here. So that's how we predict this stuff. All right. This is the second example. Now this is asking more specific questions. The information is right here. We have a scatter plot. Notice it doesn't give us a line. It might be good for us to draw one if there is a pattern. It also gives us a chart with all of this information as well. So each one of these points right here, here, and here matches up to one of these guys. So this is comparing the number of years since the year 2000 with the number of pictures added to a database, so like a computer database. So here it says, what do the values on the X represent? Remember, this is our X. So this is number of years since 2000. So I just wrote that, number of years since 2000. What does the Y represent? Our Y is here, remember. And that's the number of pictures added to the database each year. So like in the year 2000, because that's 2000 plus 0, about, maybe like 350 were added. After 1 year, which would be about here, there was a little over 400 added. And then after 2 years, it kind of stayed the same. The year after that, it dipped down, then it goes, just like that. How would you describe the association? So this would be kind of where we would draw a line. So we would kind of start, where it began, and it's just a slight positive. So it's something like that. So we know that it's positive because of that. It's not a huge positive curve, but it's still going up. So we know it's positive, and because there is a straight line on that, it is also linear. Remember, linear means straight line. Now we're also getting into the idea that we can have an equation attached to this line. Think back to when we did y equals mx plus b, where your m is your slope, your rise over your run, and your b, that's your y-intercept. So with that, and these two things in mind, we can come up with an equation for this line I just created. And remember, it's just an estimate. So I already gave you the answer, but I want to show you how I got that. So we know this is a positive, so that means that our slope should be a positive number, right? Then our y-intercept if we look here, this is where it crosses a Y, and it's a little bit above 350. And if we look at our options here, our B, what we're adding after the fact, is about 366. So that's why I picked that one. And then it would only make sense that, I think it froze. Hold on one sec. Okay, we're back. So it only makes sense that if you're adding 366, which is your y-intercept, and you have a positive number in front of the x, which is your slope, it would be that 8x plus 366. Let's try to get this image a little better. Okay, sorry if it's a little blurry, guys. The final question here is saying, in approximately what year is a Tampa Tribune expected to add 700 new pictures? So if we know it's going to be 700, we're going to take this equation and we're going to set the f of x equal to that 700 number. So I put 700 is equal to 8x plus 366, and we're going to solve for our x. That's going to say what year we're in. So I subtract 366 from both sides, you balance it out. We're then going to get 334 equals 8x. To get rid of a multiplication of 8 on the right side, we divide by 8, got to balance it out, and we get about 41.75. Now it's not the year 41.75, it's, remember, years since 2000. So that's why we're going to add 2000 to the 41, we'll say ish, because it's more of an estimate because of that decimal. So 2041 makes 2041. So in the year 2041, around 700 pictures will be added in that year. And that's just a, that's following the pattern. It's not exact, but if we follow this pattern, it'll be somewhere around this line right here. All right. Sort of similar to that last question, we have a scatter plot here. It says the scatter plot below shows a number of violent crimes committed in the US for the years 1993 to 2012. So our starting year, which is right here, that's 1993. It even says here, years since 93. So it says that there's a linear equation that represents this. It's negative 31,256x plus 1,773,900. We're dealing with some big numbers. X is a number year since 93, and Y represents violent crimes here. I don't know why this is so blurry. Sorry, guys. Assuming the trend continues, use a model to predict the number of violent crimes in the year 2020. So in this first step that's right here, we're not going to just plug in 2020, because if we look at this, it's a number of years since 93. So like 2 years after 93 would be 1995. 4 years would be, 97, so on and so on. So what I need to do is find out how many years are in between 1993 and 2020, what we're trying to find out. So I take the difference between those two, I subtract them, and I get 27. That's the number that we're going to plug in to our equation. So we have our slope, which is negative, because generally there is a negative slope. I multiply that by the number of years since 1993, and I'm adding my y-intercept, which is right around here. So if I multiply these guys, I get negative 843,912 plus 1,773,900. I then add those together. Keep in mind this is negative, and this is what I'm getting. So in the year 2020, the number of crimes should go down to 929,988. So, it's going to be around here somewhere, if you kind of kept this line going. One more final thing, and then I'm done, guys. So we want to be able to just describe a general idea of what scatter plots look like. And this is just like a vocabulary question. It's looking back at some of the units that we've gone over in the past. So generally, when we look at this, we see that there is a straight line, right? So linear is a straight line. If something is quadratic, you remember in the giant quadratic unit that we had that lasted like 2 months, that's where we have a curve happen. So generally with quadratics, you know, there's a mirror image. Now it's a scatter plot, so there's data all over the place, but it kind of fits this parabolic curve here, a parabola. So if you see a parabola happen, it's quadratic. Now this one starts here, and then if we follow it, there is a curve, right? So if there's just a curve in it, that's exponential. That was in 2 units ago. And of course, this one is a little hard to see. You know, there's a point here, 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 here. Now, it's a little bit of a stretch, but we could make a parabola just like that, making it quadratic. All right, so that's the first lesson, guys. The next few are going to be a little funny. They might be short. They might just go over a little bit of vocab, but try to get these basics down for scatter plots. They're going to be the most important part of this unit. We have 5 lessons here, so basically we have 2 lessons in each week. So lesson 1, lesson 2, and a review will be this week. Lesson 3, lesson 4, and a final review will be the next week. And then we'll have a final lesson on that Monday, Tuesday, and then we'll test on that Wednesday. So hopefully this testing and lesson is working well for you. Let me know if you guys have questions, and then we'll go from there. And if you're doing any of the past Khan Academy work, guys, please fill out the Google form that's on Canvas. I've had a lot of people just say, hey, update my grades. I'm not gonna, like, I don't have the time to kind of go through and check what you did and what you didn't do again, because I already did that. So please fill out that form. If you tell me to update your grades, I'm just gonna ask if you filled out that form. So yeah, I think that's about it. All right, thanks guys.